IBAISL, Limestone 1, Paper 2, May 2024. Question 1. We let y be the price of an apartment and x be the distance from the city center. We are given 6 data points. Most parts of this question can be solved by entering the data into the calculator. For part A, we need the Spearman's rank correlation coefficient. The calculator gives R as equals -1. We also find the Pearson's product moment correlation coefficient R, which is -0.979. The best two words to describe this correlation are negative and strong. Next, the relationship between x and y is modeled by the regression equation. From the calculator, we get A equals -0.0992 and B equals 3.19. Here, B is the y-intercept of the line, which represents the price of an apartment in the center. For part D, we are told that the distance is 19.6 km, and we want to estimate the price. Substituting x equals 19.6 into the regression line gives y equals 1.25 million. We also need two reasons why the estimation is valid. First, 19.6 is between the highest and lowest x values of our 6 data points, so this is interpolation. Second, R is very close to -1, which shows a strong correlation. Finally, we carry out a t-test at the 5% level of significance to check if the mean price in region A is different from the mean price in region B. We assume the population variance are equal. The new hypothesis is mu A equals mu B, and the alternative hypothesis is mu A not equal to mu B. Using the calculator, the p-value is 0.0224. Since this is smaller than 0.05, we reject the new hypothesis. One extra assumption we must state is that both populations are normally distributed. Question 2. We let T be normally distributed with mean 64 and standard deviation 12. The probability that T is smaller than 64 is just the probability of being less than the mean, so it equals 0.5. For part B, we use the calculator and get 0.452. Now, we are told that 30% of the packages are delivered in less than 8 hours. To visualize this, we sketch a normal distribution curve, mark the mean, and shape the region where T is smaller than K. Since P of T smaller than K is 0.3, we use the inverse normal function on the calculator and find K equals 57.7. Next, the manager takes 5 packages. If we let X be the number of packages delivered in less than K hours, then X follows a binomial distribution with N equals 5 and P equals 0.3. For part D, we want to find P of X equals 2. The calculator gives 0.309. Now, we consider the charge. There is a fixed charge for packages weighting 1 kg or less. Any excess above 1 kg is charged at $2 per kg. So, for weight x greater than 1, the total charge is x minus 1 times 2, plus the fixed charge of 4.5. Simplifying, the expression becomes 2x plus 2.5. For a package of 5.3 kg, we substitute x equals 5.3 and get 13.1. Finally, we want the weight of a package that would be charged $7.2. We set 2x plus 2.5 equals 7.2, solve the equation, and find x equals 2.35. Question 3. We let n be the number of smoothies and x be the price. N is 400, and we want to find the corresponding price. So, we substitute n equals 400 into the equation and solve for x. If the price is 50, we want to find n. Substituting x equals 50, we get n equals 16. The total income is price times number, so 50 times 16, which gives 800. Next, the cost of each smoothie is 20, and P is the total profit per day. The expression for P is the number n times the price minus the cost. After simplification, we get the required formula for profit. To differentiate P, we first rewrite the terms in powers of x, then apply the power rule. Setting the derivative equal to 0, we solve algebraically. By multiplying through by x cubed, it becomes a linear equation, and we find x equals 40. Profit is maximized when the derivative is 0, so we substitute x equals 40 back into the original equation to get n equals 25. Question 4. A generator has two switches, A and B. The probability that switch A fails within 1 month is 0.1, and the probability that switch B fails is 0.3. The two switches fail independently. If both switches fail, the generator shuts down. For A, the probability that switch A does not fail is 1 minus 0.1, which is 0.9. For B, the probability that switch B fails is 0.3 as given. C. The probability that switch B does not fail is 1 minus 0.3, which is 0.7. Next, we want the probability that the generator shuts down. That is the probability that both switches fail, which is 0.1 times 0.3, giving 0.03. The owner is suspicious of the manufacturer's claims. He looks back at 200 past occasions when the switches were replaced. A table shows the number of times no switch failed, one switch failed, and two switches failed. We want to show that the expected number of occasions with no switch failing is 126. The probability of no switch failing is 0.9 times 0.7, which is 0.63. Multiplying 0.63 by 200 gives 126 as required. For Part D, we carry out a chi-square goodness of fit test at the 5% level of significance to check if the manufacturer's claims are correct. First, we find the probability of each situation, and then the expected number of each by multiplying by 200. With degrees of freedom equal to 2, we use the calculator and find P equals 0.182. Since this is greater than 0.05, we cannot reject the null hypothesis. Question 5. Let x be the distance and h be the height. We know that h prime of x is given by the expression in the question. For part A, we want the slope of the water's line when x equals 2. So we substitute x equals 2 into h prime and we get negative 1.2. Next, we want to find h of x. To do this, we integrate h prime of x. Since we know that when x equals 4, h equals 1.4, we can substitute this into the equation to solve for the constant c. For part C, we want the area of the shaded region. That means integrating the function h from 0 to 4. The result is 5.6. For part D, we know the width of the water's line is 1.2 meters. The volume is just the area we find 5.6 multiplied by the width 1.2. For part E, we are told that h of x has a new form with constant a, b, and c. We are also given 3 extra conditions. From each condition, we can write one equation in terms of a, b, and c. For the first condition, substitute directly into h. For the second condition, differentiate h first and then substitute. For the third condition, do the same to get equation 3. With these 3 equations, we can solve the system to find a, b, and c. Finally, we explain why the update design still provides a smooth path at x equals 2. We check both the old and new functions. At x equals 2, the slope h prime is negative 1.2 for both, and the height h is 1 for both curves. Since both slope and height match, the path is smooth.